Here we are trying to understand two concepts, angle of friction and angle of repose, with respect to friction. Let us begin with angle of friction. Let us say we have a surface on which we have an object placed, a horizontal surface, and let us say this object is on the verge of moving in this direction. So it's just about to slide in this particular direction. Now the forces which come into play when it is just on the verge of moving are mg and its normal reaction r, and the frictional force. The frictional force will come into play in this direction. So this we will call as Fs, where Fs is the maximum static friction, or what we call as the limiting friction. So these are the two forces which come into play, mg, r and Fs. Now we know from the vector theory that a force or any vector which represents a force can be placed at some other location as long as the magnitude and direction remain same. So what I can do is this particular arrangement I can show in the form of maybe vectors, right, placed. So if I show it over here at some other location, say for example I show this as r, and let us say I show friction Fs. Well, in fact, let me show them a slightly bigger. So let us ignore this part. Let me show them a slightly bigger magnitudes. So let us say this is the normal reaction R and this is Fs. And if I want to find out the resultant of these two forces, what I'll do is I'll complete a parallelogram like this, and then this particular vector, for example this one, if I can call this R1, vector R1, this would represent the resultant of these two forces, Fs and R. And this particular angle theta, the angle between the normal reaction and the resultant, is known as angle of friction. So angle of friction theta. So this is what angle of friction is. Let me put it over here, for example. The angle of friction is the angle between the normal reaction, this is the normal reaction, and the resultant of normal reaction and limiting friction. The resultant of normal reaction and the static friction. This is angle theta. If I take tan theta would be R1. This is R1 opposite side. I'm calling these as points R1. Actually R1 represents this vector, R represents this vector, but for sake of simplicity I'm calling this point also as R1, this point as R. Let us call this point O. Then tan theta would be R1 opposite side upon adjacent side OR. Now what is R1? If I try to show it over here, this is Fs, for example, this is R1. Now R1, this is O, this is R1. R1 is Fs, so I'll get Fs. And what is OR? OR is nothing but the normal reaction R. So tan theta is Fs upon R, and we know that the ratio of the limiting friction and the normal reaction is the coefficient of friction mu, and therefore we get this equation, tan theta is equal to Fs by R is equal to mu. What this means is the tan of angle of friction is equal to the coefficient of friction. This coefficient of friction quite obviously is the coefficient of friction of these two surfaces, the surface of this object and the material of this surface. So if I know the angle of friction, I know the coefficient of friction, or the other way around. If I know the coefficient of friction, I know the angle of friction. So this is what is angle of friction. What I'll do is, just to create space, I will probably put it over here. Okay. Let's move to the next thing, that is angle of repose. Angle of repose. So let me say there's an inclined plane. Let us say this is an inclined plane, right? And let us say I have an object, the same object placed over here. Now, as we know, this object will have a tendency to slide down this inclined plane. Let us assume at this point in time that it is not sliding down; it is stationary over here. So, if I increase the angle, right, let us say this angle has got some value. Let us say to begin with, say 7 degree, and let us say I increase it 8 degree. This object's tendency to slide down increases. And if I increase it to 10 degrees, its tendency to slide down will increase further. And at one particular angle alpha, this object will just start to slide down. And this angle alpha is known as the angle of repose. So this angle repose is the minimum angle of the inclined plane at which an object starts to slide down. So let me put it over here. Angle of repose is the minimum angle of an inclined plane at which an object placed on it starts to slide down. If I try to draw this object and look at all the forces, I will have something like this. The object is tending to move in this direction. Let us say this angle is, say, alpha. So the forces that come into play are mg acting in the downward direction. Normal reaction will be perpendicular to the surface like this. So this is the normal reaction R. Now let me make this slightly longer so that I'm able to draw a better diagram. Now this force mg, it has two components. One component is keeping it on the inclined plane, right? Keeping it on it's acting in the downward direction. It is forcing it to stay in the downward direction, meaning it is forcing it to stay on the inclined plane. And there is another force which tries to take it in the downward direction. So if I want to find out the two components of mg, I can show them like this. Probably I'll use a different color so that I'm able to distinguish. This is one component and this is the other component. Show them by arrow, and this is arrow. So this component is acting in the downward direction. That means it forces this object to stay on the inclined plane. And this is acting in the downward direction. As you can see, it is acting along the inclined plane. This component tries to take it downwards. The other thing that we see is that if this is alpha, then this angle also is alpha. We can prove that geometrically, but right now we will not get into that derivation. Right now we will assume that this f is alpha, this angle is alpha. So if I take tan alpha, let us call this point O, let us call this point A, and let us call this point B. Tan alpha will be AB upon OA. Tan alpha will be AB upon. And now what is ABE? AB is the force which is acting along the inclined plane. And one thing which I forgot mentioning right while we are putting those forces, there's another force, Fs, which comes into play, which I should have mentioned when we drew these forces. So what is AB? AB is forcing it in the downward direction. And if it is in equilibrium position, that means it is just on the verge of moving, right? Or it is on the verge of moving, but it is not moving. So it is still in the equilibrium condition. At that point in time, this AB, which is trying to take it down, will be equal to Fs. So AB can be written as Fs in equilibrium condition, or when it is just about on the verge of moving. And what is OA? OA is equal to R. Because it is not moving down, it is stationary, it is in equilibrium. So Fs will be equal to R. And Fs upon R we know is coefficient of friction mu. And now, if you look at this and if you look at this, you find they're exactly same. And therefore we can say tan theta is equal to tan alpha. Tan theta is equal to tan alpha. And therefore theta is equal to alpha. That means angle of friction is equal to angle of repose when the object is just on the verge of moving, when it's just on the verge of sliding down an inclined plane. Basically, why they are equal, or why this? Here we took a situation wherein the surface is horizontal, and you could imagine that we are increasing the angle, and at angle theta, if I draw this diagram over here again, this is it. And let us by some means I'm increasing this angle. That means if this surface is horizontal, now I'm making the surface this. So the object would take up this position. And as I keep on increasing this angle, the angle would increase. And at a situation when this particular angle of the inclined plane is equal to the angle of friction, theta, this would start sliding down. So essentially both of them are connected to each other. And therefore it turns out that theta is equal to alpha. Final point just to stress on is the fact that we're looking at all these situations when the object is on the verge of moving. So this frictional force is Fs, which is limiting friction force. Right? And if you remember the diagram of the forces, frictional forces, we had a diagram something like this. And this we said is the limiting friction Fs. So all this discussion is around this force, the maximum static friction, or what we call as the limiting friction. Thank you.